Welcome to the lesson on the collection and presentation of data. At the end of this lesson, you will be able to appreciate the importance of the collection of data and distinguish between primary and secondary data. You will also be able to define frequency of data and arrange the given data in ungrouped and grouped frequency distribution tables. Delhi records hottest day in 20 years. Biggest fall in Sensex in 5 years. Afridi scores the fastest century in one-day cricket history. India's population to overtake China by 2030. You must have seen these headlines in newspapers. Have you ever wondered what makes such headlines possible? These headlines are possible only because some people or organizations are continuously maintaining a record of quantities like temperatures of different cities, the rise and fall of Sensex, scores of different batsmen in different matches, or the population of India. A systematic record of facts or different values of a quantity is called data. Such records or data is collected over a period of time and continuously updated. Data is collected with a specific purpose in mind. However, the analysis of data can give us many different kinds of information. For example, data collected in a population survey in a state not only tells us about the total population of the state, but also the number of male and female residents and the male-to-female ratio in that state. Data is not just about population surveys or cricket scores. Data is continuously being collected all around us through scientific experiments, opinion polls, election results, satellite images, and much more. Even your report card is just a collection of data about your year-round performance. All this data not only helps us keep track of current happenings and trends, but also helps us predict what might happen in the future. The school authority wants to deploy a school bus for their students coming from a particular locality. Our friend here is assigned a project to find out how many children in the school come from that locality. Now, how would he collect this data? One way to collect this data is that he personally speaks to every child in each class to find out where that child lives. The data collected personally by him is called primary data. Primary data can be collected through questionnaires, interviews, observations, case studies, portfolios, etc. It is quite difficult and time-consuming. A far easier way for our friend would be to approach the school authorities and get the names and addresses of students coming from that particular locality. The data gathered from a source where it already exists is called secondary data. You can see that collecting secondary data is far easier than collecting primary data. Mrs. and Mr. Longlife are both in their 90s, and they have a happy joint family. A rather large happy joint family. Let us look at the ages of all the members in this family. It would be interesting. As you can see, the data of ages of the different members of Mr. Longlife's family is quite an interesting mix. Can you notice the ages of the oldest and youngest members of the family? Let us see if we can present the data to make this observation easier. We can make the observation of highest and lowest values in given data easier by simply arranging the data in ascending or descending order. Here, we have arranged the ages of Mr. Longlife's family members in descending order. The highest and lowest values in the given data are of special importance. The difference between them gives a number that is called the range of given data. Here the range of the given data is 91. Meet Mr. Pinch Hitter. Sadly, he's not in the best of forms this season. Here he goes again for a duck. Have a look at his scores in the last 15 innings. Can you immediately notice how many ducks he scored? Let us see if there is a better way to present this data. Now, on arranging the given data in a tabular form, it's clear. Mr. Pinch Hitter was out for 0 5 times in the last 15 innings. He got out after scoring 2 runs in 2 innings, 9 in 1 innings, and so on. Note the second column on this table shows the number of times a value occurs in the given data. This is called the frequency of that value of data. For example, here the frequency of 0 is 5 and the frequency of 16 is 3. Remember, this table was created to present Mr. Pinch Hitter's scores in the last 15 innings. Since this table shows the frequency of different values in given data, it is called a frequency distribution table. The frequency distribution table shown here gives the frequency of each individual value in the given data. It is called an ungrouped frequency distribution table. Is there any other type of frequency distribution table? Let's find out. Now, consider Mr. Pinch Hitter's scores in the last 45 innings. If we make a frequency distribution table like the one we made before, it would be a long table and difficult to read. When we deal with large amounts of data, we create what we call grouped frequency distribution tables. Let's take a look. Now, what have we done here? We have grouped the scores into classes like 0 to 9, 10 to 19, and so on. Note that this table does not show a frequency of individual values of data, but of groups of values. Each group has a fixed number of values. A table that shows the frequency of groups of values in given data is called a grouped frequency distribution table. You can see from this table that Mr. Pinch Hitter has reached scores in the 40s 10 times in the last 45 innings, but hasn't hit a half a century. Guess he needs more net practice. Okay, coming back to our grouped frequency distribution table. The groupings 0 to 9, 10 to 19, and 20 to 29, etc. that we use to group the values in given data are called classes or class intervals of the frequency distribution table. Note that each of these classes contain a fixed number of values, which is 10. The number of values each class contains is called the class size or class width. Now look at a particular class. Say the first one, 0 to 9. The lower value in a class is called the lower class limit, while the higher value in the class is called the upper class limit. Can you identify the lower and upper class limits in the class 0 to 9? Yes. 0 is the lower class limit and 9 is the upper class limit for the class interval 0 to 9. Tally marks are also used to represent frequencies of different values in a frequency distribution table. Tally marks is a system of writing numbers using bars. These bars are grouped into sets of 5. Observe how 2 such sets and 2 vertical bars are used to represent the number 12. Here is a frequency distribution table showing the marks obtained by students in a maths Olympiad. A total of 60 students appeared. 59 students have fitted very nicely in this table. What about the one who got 85.5 marks? Where does she fit in? To fit in her marks, we need to change the class intervals of this table. Let us see how this is done. To change the class intervals of a frequency distribution table, the first step is to consider any two successive classes in the table. Here, let us consider the classes 81 to 85 and 86 to 90. The second step is to find half of the difference between the upper class limit of the previous class and the lower class limit of the succeeding class. Here, this difference between 86 and 85 is equal to 1. Half of this difference is 0.5. Now, rewrite all the classes by subtracting the result of step 2 from the lower class limit and to the upper class limit of each class in the table. See how the table changes. The problem is still not fully solved. Note that 85.5 appear in two classes of the table. So where does this student's marks fit in? In such cases, by convention, we include the twice occurring value in the class interval where it forms the lower class limit. Thus, 85.5 will be included in the class 85.5 to 90.5 and not 80.5 to 85.5.